So, guys, today is the data modeling masterclass, day one. This is from what we discussed in the previous video on day zero, wherein we went through all the topics which we will cover. And day one, day two, day three, day four, day five, day six, day seven. Today we will deep dive into um, day one, what we will cover. Um, so, so this is applicable for all the beginner, intermediate, and advanced users. So on the first day, this is as you know, the protagonist is a insurance claims agent uh, who will be building a data model of around 100 tables um, across to make it simple. I made it simplistic in the sense of understanding, not in the not in the complexity. um, so there will be one domain for each, created for each day. So let's start with the business questions. What are the key stakeholders for this insurance data model, applicable particularly for the claims portfolio of an insurance organization? Um, who are the stakeholders? Who are the people, and who are the organizations involved in this activity? Um, so basically, we need to represent how the policy terms, the policy versions are applicable at that point in time. What was the version of that policy? What was the price of that of the cover? What was the limit? What was the coverage? But all are applicable at that point in time, right? You can have a multi-year policy. In first year, you can have a insurance limit of X, and another year you can have an insurance limit of 2X. Um, so um, the accident, if it happens on that year, on a particular time, what is the what are the conditions applicable? So the data model is a storage mechanism which has to store point in time. Point in time is a good keyword which you should keep in mind for our data modelers. Point in time. Point in time. This is used in disaster recovery and HS scenarios as well. But here in data modeling, point in time means what was the value at that point in time. Okay. How do we capture multiple addresses? This third key activity is how do we capture multiple activities, multiple addresses, sorry, and contacts per party. A party can be a claimant, can be an organization, um, and it can have multiple addresses, like a policy holder can have a house address, an office address. He would have met an accident while he is going to office, and the car was in the office parking lot. There was a theft in that car, or there was an accident. Um, and then there are specialized cases wherein the car is present in garage, or it has been mortgaged to another party. So then how do we so that is one area which we will cover, and then all this in day one. Okay. And then how do we model different risks, different types of risks? Theft, as I said, accident, uh, mortgage non-payment, stolen vehicle, partially damaged, puncture, um, which called very called a home assistance. Uh, so And then there are different products. So a vehicle insurance company will have various products, right? Nowadays they have metering products where they put a meter under your dashboard so that they know your driving behavior, and based on that they collect the telemetry, and then they provide uh, they provide a better deal to a safe customer. Okay. um, so these are the questions which will be addressed by the data modeler, and these are the key business questions which a data modeler should get answers. So you have to ask a data modeler should ask such type of open-ended uh, many to many, one to many, recursive, how to store. From that, he should come from that background. And but when he asks, he should ask, um, who are the stakeholders? As my first point says, how do you want a policy version to be stored in a point in time? Do you go back to history? Let's say somebody wants to go back to 3 years back incident and wants to dig out everything of a claim which he got a bad redressal. You have to do that, right? As per regulation, you should do that. But in some cases, no. In some countries, finish claim, finish, that's it, finish. um, um, then how do we capture multiple addresses? This you would have seen in Amazon and all. A person like, I have 12 addresses, one in India, one in Ireland, one in the USA, or five in somewhere else. So five friends addresses, two hold my packages, so two post boxes. So so this is address is very common across all data models. So this you have to refine yourself and to um, come up with uh, a quick solution, a quick data model to impress the audience. How do you model different insurable risks? Yeah, these are lines of businesses, and how do we keep the products configurable? Yeah. And so um, uh, that again addresses what I was talking earlier. So what are the now we'll go into something and what are the modeling options which will be considered, um, uh, or the modeling options which will be taught in this day one. So one is party modeling. This is a very classic example. I will throw a little bit of history here. I was working in a IBM banking data warehouse model where first time I had encountered party as a table. I was shocked. What is this party? So this is a party is nothing but a person. So a person or an organization, depending on its role. Uh, so it is a abstract form of an entity, which could be a person or an organization. You can say things like that. Uh, uh, this is where either the person will have that person will have will buy the car, or the organization will buy the car. Those who buys the car, those who buy the vehicle, those who create, those who need the insurance. So it's not like policy. Policy is just a document which says this. So party are the one who are the active persons. You can say like that, an active persons in this business. Then policy changes. We will cover policy changes. Um, how do you store versions, as we covered in the first slide, and how do you um, how do you override some of the policy fields which you feel are quite do not need do not need a maintenance of history. Then there are address per party, array of addresses. You can do single. You can have single address per party. You can have array of addresses, and then you can build a contact table where you have list of addresses, and then um, uh, you can have a bridge table so that you can map that party to that address. And addresses are like like address in UK or Ireland are held by post office, and you can buy from post office, and you can populate the entire um, address database. You can create an address database, and then you can create what you can do is that from the policy and address database, you can have a bridge table, so that one person can live in multiple addresses, but other person also could be living in the same address, right? So that can be captured. Then there are risk objects. Risk objects are what is the generic type of with risk discriminator, like what is the type of or risk, property risk, a vehicle risk. And you can build that as a JSON-B extension as well, wherein you can cover the risk demography as a JSON-B, which with all his history, and you can just search that if you have any doubts, or you can build a different table out of it. So there are multiple options depending upon where you are as an organization, how mature your organization is, how much business you have. You should not build something which is 10 years old. Generally, what I say is that build what will last for the next 2 years. 2 years, yeah. Um, um, Product config. Um, yeah, this is the key features of the products, whatever the products the insurance company sells, um, whether it is a telemetry product, a vehicle telemetry product, or a vehicle home assist, um, vehicle theft. Uh, yep. So then we will try to provide a reasoning of why this path was chosen. So let me quickly show you the entire model so that um, it gives a breakup of your it gives a good overview of what you are s- um, what you're about to see that. um, do, do, do. So here, these are the models. So if you see here, the number of tables which are present is 100. So today we will present, we'll cover the first domain, um, which are these 14 tables of the core domain. So if you see, this is a data modeler, so you can see these are the tables which are present, the 100 tables. Quite big, right? Looks so interesting, and looks like you're really working on engineering, right, guys? So so first one, as we said, we'll cover party. What is party? Oh, here it is, party. So since this is the base table, core party, this is a master table. You will not have, you'll have foreign keys pointing to it, but this not referring to others, right? So if you go to party contact, say party contact, now you'll have, see this arrow, it says, oh, show party. So it is connected to party. So this part, it has references, right? So that's why. So it has a party ID and the contact channel ID. It has a reference. So if I click contact channel, it goes here. So this is a nice tool. I like it very much. Um, so I just gave you an overview of party and party contact. Then the addresses. See the address. So it is in the core. So these are all highlighted in, this is present in address domain, but we are actually working on core domain, since, and this is highlighted as address in address domain color, but it refers to a core activity, which is um, yeah, which is party address. So, and then we also looked into person policy. Person is sitting in a in an island on its own. Policy is sitting in core. Um, so we will cover core. If you see here, it's on the left hand side of the perspective. There are a lot of core tables, core policy. Um, mm, yeah. So all of the product domains, most of the tables are core, driving tables, I will say, not most are driving. See, core product, core policy, tool, role, core policy. Yeah, they're all starting. These are the incubator. These are the engine of a data model. If you don't understand policy, don't understand party, don't understand um, policy, party, bridge, gone, straight away gone. You cannot debate. Data modeling is not about building and proving it out that it is running. It's about debating with business, with developers, with business analysts, why you are doing this, what it will solve in which scenario. You have to always come up with what if scenarios. Okay. So I will next show you the day one. Uh, Day one tips, the data modeling tips. So if you see, there is a role pattern which we will cover. A separate entity party role to connect a party to another entity. Policy, claim, account with a role, code and dates. It avoids many to many chaos, allows time bound roles, supports multiple roles per party, right? That's why a separate entity party role has been created. What is a recursive hierarchy? A recursive hierarchy pattern is it it shows the multiple levels of an organization. So if you go to the core, so if you go to the core and search for organization, just like yeah, this is here. So party ID, organization type. So it doesn't say what which one is a child of that, right? It doesn't say that. Organization type and a registration number, party ID. So it doesn't talk about what is the child ID of this. So let's go back. So how do they do this? Alter table, core organization, add column, parent org ID. So he's asking for a change which supports roll-up reporting, terraces, siles, etc., sales trees, and multi-level approvals to model corporate. Yes, that's very important. With recursive chain, yes. Okay. Then there is effective dating pattern. So you store multiple records per entity, each active date for a date. So you have a concept of effective start date and effective end date. So effective start date and end date. So, but the key thing is here the constraint. The constraint relies on the party ID, role code, and the date. So you cannot have a party ID and a role code um, with the same effective date and a different end date. Okay. Lookup centralized table for domain values. So these are the reference lookups. This is where the novice or an intermediate data modeler or a pretending data modeler is good at. He will create a ref code and he will create a domain and code and value and he will spit it out very fast. They are good at it, um, because it is very straightforward from a for a novice data modeler to prove that he knows something about data model. Trust me, this is the easiest part. But um, yeah, and then there is audit trail, which we should always try to push these tables as soon as in the earliest scrums. We should push this. This is store changes as rows gather, as rows rather than overwriting. So So this is helpful for dispute handling, model training, analytics, um, what action happened at what table, what record. This depends on the granularity. Then this concept of surrogate keys and natural keys, this is very important. Surrogate keys and natural keys. Surrogate natural keys are the business keys. Surrogate keys are the ones which are created by the system. So data modeler drives those sequences, and he tries to create those surrogate keys which stay over time. Let's say the policy ID of a customer changes. Um, eh, for some reason, for some reason but if the key is the same, if the surrogate key remains, then um, you can tie with the previous policy number and the new policy number. So basically you should be independent of what the business data is. Your join should not depend on business keys. Your join should depend with business keys, with changing business keys, with deleted business keys. So how do you do that? You create a surrogate in the sense, a artificial key, a tech key. Then there is this associative pattern, which I've tried to show an example, which is basically a bridge table for many to many, like party and address are two blocks, which can have many to many relationship. So you can have a bridge table, a policy and coverage, party and contact. This is this has newly come up. This I will not say is a core data modeling activity. It is just tagging tables, tagging entities for grouping and for various tasks, various again processing tasks, not business tasks like testing, A/B testing, or data science grouping. Let's say data science teams, they want to pick a set of tables which look like the original data model, but they are yet to be modeled in a data warehouse, yet to be modeled in a structured manner. So they want to play around, and data modeler can promise to provide an alternative data pipeline, and that data pipeline will try to push to this will be tagged. And let's say you have some 50,000 patient pet insurance receipts, and to analyze that and to get into the data warehouse, it takes months, right? But the data science groups can quickly throw Python on it and try to find some heuristics about it. So this is about normalizing address, separate address structure with geometry for geo analysis. Yeah, PostGIS is very good at it. So you can store two-dimensional, three-dimensional addresses, latitude, longitude, and in UK I've seen that they use altitude as well. So three-dimensional addresses. So we can do that using PostGIS. So you have this geometry keyword in PostGIS. And composition pattern. This is called a I call it a tire car pattern generally. A coverage, a risk, a coverage form a product. But they are key, like a car and a engine and a tire are not indispensable. They are both complementary. So these are basically complementary products, not supplementary uh, uh, items, not supplementary. They are complementary. I will call it complementary components. Security, row level access, conform dimensions. Yeah. So here the super type and so a subtype is explained in detail. So there is a one, the party ID is called is a canonical ID. Canonical in the sense this is a abstract ID. You can say like that, abstract. It's not real. There is no person with party IDs, actual party table, but it is there as a person or an organization. Hold the specific, and then yeah, see this create table core party where the party type is in person or organization, and then the subtypes are each tables. Create table core dot person name, first name, last name, date of birth, organization, references party organization type, whether it's a carrier, broker, or repairer. So see how the claimant, the claims.claimant table, it refers uh, to a party ID, not a person or an organization, because they have that party ID. So this is the example of that usage of a party. Insert into core party personnel. This insert into person. You have inserted two persons, and then organization. You have inserted two records, Acme and Reg 5, and now you try to join on party ID. This is the strongest normalization, and it is a highly scalable solution. Uh, How does it look? This is very important. My whole methodology of data modeling is to teach data modeling using anti patterns. How not to do it, because it is very fine line to know, understand how to do it, and then get bogged down into that. But if you see the other side, you will see how bad and how you should not do it. So this is how you not to do it. This option B, single party table. It is very simple. You can get going fast, but you don't know what is going on. So you create a single table, uh, and then you have multiple columns for person and organization. You leave the organization columns empty. There's hard to enforce. There's weaker integrity. When there will be messiness as soon as the data grows, because there are no foreign keys. So when to choose which one? If you need a strong data quality, of course we need a strong data quality. We need rapid. What do you mean by rapid? It's, I will say, not rapid delivery. Option B is rapid delivery. Rapid delivery. We should not use the word rapid delivery. I think it is to um, to make prototypes, front end prototypes. Okay, guys. Thanks. We covered day one. Thanks for spending your time. You can ping me, comment me, reach me out for any questions. I'll be back again next day. Thanks. Bye.